We are nowhere near as smart as we think we are. You know that golden telescope we humans built? It's taken some mind-blowing pictures of space. Right now, it turns out it's so powerful it might have just shattered our understanding of the universe. The universe witnessed a stunning cosmic expansion before the Big Bang, doubling in size at least 80 times in a fraction of a second. Because of this tremendous inflation, the cosmos became barren and frigid. That's when the cosmos stopped growing in size, and the vacuum energy transformed into matter and radiation, ushering in the Big Bang's era of intense heat and density, forging the elemental building blocks that would eventually coalesce into the galaxies and stars we see today. Now, for the first time, the James Webb Space Telescope has peered into the distant past of the universe, and we have made a discovery so unexpected that it challenges our understanding of the cosmos. What was there before the Big Bang, and what is it that the James Webb Telescope has uncovered that has shocked everyone? Let's find out. There was a time when the universe did not exist, it was created. The Big Bang, which created the universe and everything in it, occurred around 13.82 billion years ago. Our Milky Way is one of around 2 trillion galaxies that formed from the expanding universe's cooling debris, which are essentially islands of stars. Scientists were dragged kicking and screaming to the idea that the universe may simply appear out of nothing. The evidence, however, is hard to ignore. Galaxies are disintegrating like cosmic bullets, and the Big Bang's afterglow is still rather warm, extremely dimmed by cosmic expansion. This afterglow is mostly detected by radio astronomers as microwave radiation, dubbed the cosmic background radiation in 1965. Where exactly did the Big Bang occur? A stick of dynamite detonates in one spot and shrapnel shoots into space as a result. The Big Bang did not occur at any location because there was no center and no previously existing void. The fabric of space-time itself manifested and expanded simultaneously in all directions. The universe is commonly compared in astronomy texts to a rising cake with raisins standing in for galaxies. Like the Big Bang, the expanding cake causes the raisins to spread apart and leave no one point of expansion. However, unlike the universe, which may theoretically go on forever, a cake has a boundary. The analogy could not be more flawed. The inflationary vacuum existed at the time of the Big Bang. Its energy increased linearly with its volume, doubling when it doubled and tripling when it tripled. If banknotes were like this, you could rip apart a stack and find endless amounts. Inflation is known as the ultimate free lunch by physicists. The inflationary vacuum grew bigger and bigger. However, it was a quantum issue. Additionally, quantum phenomena are inherently unexpected. Parts of the inflating vacuum decayed randomly all over, becoming regular, everyday vacuums. Imagine little bubbles growing in a huge ocean. The inflationary vacuum vanished inside each bubble, but its vast energy had to go somewhere. It was used to produce matter and heat. It resulted in the Big Bang. In the infinitely large inflationary vacuum, our Big Bang world is simply one among an infinite number of such bubbles. All of this began with just a kilogram of inflationary vacuum. The laws of quantum theory make it possible for anything like this to materialize seemingly out of thin air. In what ways does the Big Bang theory fall short? It is without reasonable doubt that the universe was extremely hot and dense at its inception, and that it has been steadily expanding and cooling ever since. To accommodate various observations, however, cosmologists have had to make adjustments to the theory. To begin, according to the Big Bang theory, the expansion of galaxies is driven by the attraction of matter. However, if this were the sole process taking place, their formation would take a lot longer than 13.82 billion years. To account for this discrepancy, astronomers postulate that unseen dark matter has a mass 6 times that of the visible stars and galaxies, hence increasing the rate at which galaxies develop due to gravity. Also, according to the fundamental Big Bang theory, the expansion of the universe is slowed by the gravitational attraction of galaxies, which functions like a web of elasticity. However, in 1998, astronomers found evidence that the expansion of the universe is accelerating. They resolved this by speculating on the presence of dark energy, which is imperceptible, fills space, and has an adverse gravitational pull. The reason why the universe keeps a constant temperature throughout requires one further adjustment to the fundamental hypothesis. In order to explain this, astronomers propose that the universe initially began as being smaller than anticipated before experiencing an extremely rapid expansion in its first split second, or inflation. This was caused by an inflationary vacuum, which is a highly energetic variation of the vacuum already present in space. Suppose the Big Bang wasn't the first thing that happened. What then was there? In yet another of its many successes, the James Webb Space Telescope has sent back a stunning image of that tiny location, unlocking previously unknown information about the Big Bang. The telescope's aim is to discover light from the first stars and galaxies, and it was launched on Christmas Day in 2021. The main goal of Webb is to identify the let there be light moment after the Big Bang, when stars and galaxies first began to form. The potent $10 billion telescope, which has been in development for 25 years, is seen as the 32-year-old Hubble's replacement. Since its successful deployment, it has taken magnificent pictures of galaxies that were created just a few 100 million years after the Big Bang, and moments before a star dies. Webb has taken the first direct image of an extrasolar planet. It has been used to capture stunningly precise photographs of the Tarantula Nebula, a region home to hundreds of newborn stars previously unseen by humans. The telescope has also revealed new hidden stars and the fine structure of enormous clouds of gas called the Pillars of Creation. The recently released image shows NGC 346, an object that is a part of the Small Magellanic Cloud SMC, a dwarf galaxy that is only 200,000 light-years away from Earth. As is the case in many regions of the present universe, NGC 346 was already well known as a nursery for young stars. These regions are known to have lower concentrations of metals and other elements heavier than hydrogen and helium, which causes them to create stars more slowly than at cosmic noon. The development of stars is aided by the heavier elements that make up space dust, but due to their low metal content, present star-forming areas are assumed to be largely dust-free. They still produce stars, just not as quickly as they did when they were forming at the cosmic noon. However, Webb scans of NGC 346 showed exactly the opposite of what was anticipated: massive dust clouds that hastened the creation of stars. As opposed to the Small Magellanic Cloud, a galaxy at cosmic noon would have thousands of NGC 346s instead of just one. According to Margaret Mixner, the study's primary scientist and author of the new image, even though NGC 346 is now the sole major cluster in its galaxy that is actively generating stars, it provides us with a fantastic opportunity to investigate the conditions at cosmic noon. The abundance of dust in NGC 346 supports the hypothesis that galaxies during the cosmic midday were similarly heavily covered in dust, thereby providing a close-up artifact of the early universe. Additionally, it implies that NGC 346 may be creating planets in addition to stars by accreting them from swirls of metallic dust. If such is the case, it indicates that Earth-like planets may have originated at the same time as the cosmic midday, considerably earlier in the history of the universe than previously thought by astronomers. It is indisputable that the new Webb image is another stunner from a machine that has been in orbit for just over a year and has done everything its designers and mission planners have asked of it. This is true regardless of the chemistry and stellar physics at play. This stunning image joins a growing collection of breathtaking cosmic panoramas transmitted to Earth by the telescope. In addition, the James Webb Space Telescope has also allowed scientists to peer back into the cosmos's infancy, where they made a surprising discovery. 6 huge galaxies that existed between 500 million and 700 million years after the Big Bang that started the universe were now discovered by the Satellite Observatory. The revelation has totally changed how scientists currently think about how galaxies came to be. These objects are much larger than anyone anticipated. When looking for galaxies in this early stage of the universe, scientists expected to find only tiny, young, newborn galaxies. Instead, they found galaxies as mature as our own. The telescope uses infrared light to examine the universe because this wavelength is undetectable to the human eye and is able to pick up the feeble light emitted by old stars and galaxies. The observatory can literally look back in time to around 13.5 billion years ago by gazing into the faraway universe. What many of us had believed to be established science has been upended by the discovery that massive galaxy formation started extremely early in the history of the cosmos. These objects, which we have colloquially dubbed universe breakers, have thus far lived up to their moniker. Scientists need to reconsider how galaxies started and evolved, since the galaxies are so enormous that they disagree with 99% of models describing early galaxies in the universe. According to the prevailing idea, galaxies started out as little clouds of stars and dust that developed through time. It casts doubt on our current understanding of how early galaxies formed. It's also possible that the galaxies found with Webb's data are something else. Later, it was remarked that it's important we keep an open mind about what we are seeing since this is our first glimpse back this far. Although the data suggests these objects are galaxies, they might instead be enormous black holes. But no matter what we discover, the James Webb Telescope has shown that the cosmos is far more intricate than we could have ever imagined. So what was there before the Big Bang?